Hi, in this video here, we're going to continue talking about global unicast addresses. Here, I'm going to show you how to manually configure an IPv6 global unicast address on both routers and also on hosts. Okay, so global unicast address, manual configuration. What we're going to take a look at here is the manual configuration. Okay. We'll also look at manual with EUI 64. Later, we'll take a look at how these addresses can be configured automatically or dynamically. So here we have router R1. Let's go to gigabit 00. And all we do is say IPv6 address, and we give the address itself. Notice that it's the prefix length follows the address with no space here. That's all there is to it. No shutdown, exit. Let's do the gig 01 interface as well. And it's that easy. Okay. And let me back up here to show you something else too. Notice that if we are a /48, so let's say that what we got from our provider was 2001 DB8 Cafe. That's how they recognize us. Well, notice what we have for our subnets. So our subnets would be, given that we have a /64 prefix length, our subnets are 1, 2, 3, and 4. It's that easy. Okay. And for router R1, so here's the prefix length /64, right? There's the prefix, the network portion. And this part is actually the subnet portion. And these next 64 bits, all zeros and a 1, is this IPv6 address. Same thing on gig 01. Here's the prefix. Here's the subnet 2. And here's the interface ID, all zeros and a 1. It's really that easy. That easy. Okay. All right, we do show running config, and we see our IPv6 addresses. Notice that Cisco iOS displays everything in uppercase. It has done that for many years. Who knows? I think in a later iOS, they will probably go to a lowercase, but who knows? What I also want to point out here is it says here, no IP address. What is that about? Well, remember, no IP. When we see IP all by itself, that means IPv4. So we do have an IPv6 address, just no IPv4 address. Most commands in Cisco iOS, IP by itself means IPv4. The same command typically is used for most configurations and verification, we just add or append v6 to the end. It's slightly different in that we use for here, of course, a prefix length with no space. All right. Show IPv6 interface brief. We can see our 2 global unicast addresses. Notice we have these link local addresses. Where in the world did they come from? They were there automatically. Okay? When we created the global unicast addresses on this router, on these 2 interfaces, the router said, well, hold off a minute. I also have to have a link local address because that's what is mandatory. We'll talk about link local addresses in the next chapter. Okay. The interface is up and up. All right. Let's take a look here. What else we've got? Show IPv6 interface gig Ethernet 00. Some things to kind of notice about this command, which is kind of cool. First of all, it shows us our link local address right here. It also tells us our global unicast addresses. We can actually have more than one. Unlike IPv4, you can have multiple IPv6 addresses. We'll talk much more about that later, why that occurs especially on host computers and devices. But here's our global unicast address, and it also tells us what subnet it belongs to. Okay, the first 64 bits is right here, as indicated by the /64. It also tells us what multicast groups we belong to. We'll look at these more later. Okay. This multicast group here, by the way, is the all IPv6 devices. Okay. We'll look at some of these other ones. These actually happen to be solicited node multicast addresses. We'll talk about those more later as well. But it'll all make sense. We'll get there. A lot of good stuff. Okay, I got this thing hanging out here. We'll get there in a moment. Let's take a look here. So I do show interface gig 00. Okay. Notice what it's showing me, because I'm not saying IP or IPv6 here. What's going to give me is the hardware information and some of the basic non-IP information, including this here, which is the MAC address, also known as a burned-in address. Okay. If I configure interface gig 00, I can do this option here. I can say IPv6 address, give the prefix, the network portion. But notice what I'm not doing is specifying a host address. I've put a question mark here, meaning what are my options? Okay. Anycast is an option, meaning if I say anycast here, anycast, what it will say is I'll make this an all zeros address will be an anycast address. But let's not worry about that. That's not what we're here for. What I want you to look at is this here. EUI64, there we go, is an option. By the way, I can also just hit carriage return, enter, and it will assign my interface an address with all zeros. Yes, that's a valid in IPv6. But we're going to look at this EUI64 option. Let's take a look at what that does for us. So IPv6 address, I'm just giving the network address, all zeros in the host portion, and I'm saying EUI64. Notice that our network, our prefix length is a /64. That leaves 64 bits for the interface, which is the most common. I mean, that's always what we want to use for our addressing, unless we have a specific need to use something other than a /64 address. But we will get there. Remember, /64 subnets and /64 addresses on our devices. Okay, but we will get there. Okay, I'm just going to say end here. I'm going to use EUI64. What did that do? Let's take a look at our IPv global unicast address. There's our EUI64. Look at our global unicast address right here. So it took the prefix portion, the network portion right here, and then it said for the interface ID, use EUI64. So that's what it did. What did it do? Look at what this looks like compared to our MAC address. It's identical except for one digit, the second digit. So what it does is, we'll learn more about EUI64 later. Matter of fact, it tells us right here that the address was created using EUI64. What this command here does is it grabs our Ethernet MAC address and creates our interface ID. The only thing that's different is this second digit here. What did it do? We'll talk about that later, but the 7th bit got flipped. So this is an 8, the 7th bit got flipped here. It got flipped from a 0 to a 1, which we call flipping the bit there. 0 to a 1, and that made this an A. Okay, we'll learn more about why that's the case later. Okay, but basically what it did, EUI64 does, is it takes the Ethernet MAC address and creates an interface ID. By the way, this can be done on serial interfaces that don't have an Ethernet address. It will just grab the Ethernet MAC address of one of its Ethernet interfaces. Okay, so that's EUI 64. Not super common, but it is used or can be used. Okay, let's take a look at how to do it on our hosts. Here's a Windows device. So here I'm just going to create our IPv6 address using the Windows GUI / using 64 subnet prefix length. And our default gateway, although it shows a global unicast address here, so it's showing this address here on router R1 to be the default gateway. Typically, this address here is a link local address. FE80 something is what we use. But we can use the global unicast address as well. Dynamically, when it's dynamically configured, automatically configured, it's going to be the link local address. We'll talk about that later. Okay, if I do IP config, there we see our IPv6 address. There we see our default gateway address. We also see, oh, it should be on this line here, but we also see our link local address. Talk more about that in the next chapter. Okay, on my Mac, if I'm going to manually configure it using the GUI, I can just go to TCP/IP here, go to IPv6 and add it here. Okay, here's actually the default gateway, the router. Here's the IPv6 address. There we go. That's what I meant right there. And there's the prefix length. Okay, on Linux, and I can do similar on the Mac as well. Linux PC, if I want to configure this device here with this address, I can simply say ifconfig on Ethernet 0 and net 6 IPv6 address and give the address and prefix length. Okay. To add a default gateway, I say route space dash capital A and net 6, add default GW gateway and the IPv6 address of the router, which can also be its link local address. I can verify this. I can verify the global unicast address. I say ifconfig. I look for Ethernet 0 because that's what I did here, right? And I can see the address. Okay. If I want to verify the default gateway, I say IP space dash 6 route show, and I can see default via. Here's my default gateway via on Ethernet 0. All right, pretty straightforward, not too hard. Okay, if I wanted to do some verifying, now what I've done here is I've actually added some static routes. We'll talk about this later. So here, what I've got is on router R1, I've created a default route to send all packets to router R2 for all networks, all remote networks. Done the same thing on router R3, created a default route to send things to R2 for all of its remote networks. In R2, I've got a static route to this network and a static route to this network. And all I did was give the remote network, here I used uppercase, here I used lowercase. That's not very consistent, but either way works. Just changing the PowerPoint, but I didn't do. Okay, but this is the remote network, and this is the next hop address. We'll talk more about this later. Okay, but what I want to show you is I can verify reachability. So on router R1, I can say ping this Linux device and just using the ping command, just like we do for IPv4. On my Windows machine, again, just say ping, just like we do for IPv4, ping, and then the IPv6 address. On Linux, we use a command called ping6. Okay, we have to use ping6 and followed by an IPv6 address. Also, I have to do Control-C because it just keeps on sending the ICMPv6 echo requests. Both on the Windows device, by the way, we can, if we want to force it to either be IPv4 or IPv6 in the ping, we can do that. So if I was pinging like a domain name, www, I can actually say ping, and I believe if it's -4 or -6 for IPv4 or IPv6, if I remember correctly. All right, that's it for the manual configuration of IPv6. A lot more coming in the next couple of videos, and then we'll even talk more about global unicast addresses in later chapters.